Alright, so this is your first of 2 videos for solving systems of conics. We're going to look at the ellipse, hyperbola, and some older graphs that we've already looked at and their intersections. So our first situation, since we do have the 2 in front and the plus sign, we are looking at an ellipse and then also a line. I just sketched in on axes on the right because I'm going to do the first round graphically, and then the second round of solving we'll do with substitution. This is an easy one to do substitution with. You have to solve your equations for y, so I'm going to take my first equation, solve that for y. Now here's where it becomes a little tricky for typing it in when you take the square root. You do need plus or minus, and there is a way to plug that in the calculator, but I will give you 2 options of ways that you can plug it in. First option, to take care of the plus or minus, you will do a bracket and then -1, 1. So the -1 would be the negative, and the +1 would be the positive version of that parentheses. And then in y2, we would put in the line. Saves you a little typing to do it that way, but you don't have to. Your other option, which is probably how you've done it previously, type the positive square root in y1, the negative square root in y2, and then the line in y3. It doesn't matter which way you do it. For this video, I'm going to show you the plus or minus option, since that's a new thing probably for you. So we'll go to our y equals. And actually, I already have this typed in, but I'm going to just do it again with you. So if we do second parentheses, that's going to give you the bracket, -1, 1. Second parentheses, close the bracket, and then second square root 1 minus 2x squared. And then you would put the 2x plus 1, which that should be pretty easy in your second or in your y2. I actually am going to make the window a little bit smaller, so I'm just hit my window button. Change your window to go from -5 to +5 on both the x-min, x-max, and then the y-min, y-max. The graph comes out kind of small. Normally zoom 6 puts you on a nice standard window and is fine, but if you can't see the graph well enough, you may need to adjust a little bit. So I'm just going to hit graph. I will sketch this picture in and label my intersection points later on. Okay, so it kind of looks circular, but it is an ellipse, just one that's not that stretched out. We're going to do second trace, intersect, number 5. Now you have to be very careful which curves you're on. So I want to be on the bottom ellipse, which I am right now, and I'm going to scroll close to the line. Notice in the top left corner, it tells you which equation you're on. I want to pick this, and then I want to pick the line. So I'm going to hit enter. A lot of times what happens is it just jumps to the other half of the ellipse or whatever you're working with. So I'm going to hit the up or down arrow until the top left corner shows me the equation of the line. Now the color calculator is nice because the colors themselves actually change if you have it in 2 different colors. If you don't have the color calculator, not a big deal. Just look at this top equation here and make sure you're on that other equation. Hit enter your that time, and then one more time for your guess. And it gives me -0.666 and -0.333. Technically, those are decimals we should know, -2/3 and -1/3. If you don't know, and you think it is a decimal that you should be able to make into a fraction, quit to a blank screen, type in x, enter. It's going to give you that, and then that fraction, and then you can hit math. Sorry, it's going to give you the decimal, and then you can change it into the fraction of -2/3. You can do that for the y also, alpha y, enter, and then do math, enter, enter. It would also put it into a fraction. So you should be able to put anything into exact value format, unless they're not exact values, because maybe they are radicals or something like that. So that's one of my intersection points. I will go and label that in a minute. And then we'll do second trace, intersect again. Now I want to be on the top part of the ellipse, so I'm just going to, and actually I hit the up arrow and it put me on the line, which is okay. So I'm just going to go up and get close to that other point, hit enter. Took me to the bottom half of the ellipse, but I want to be in the top. So just going to keep getting the up arrow until I know for sure I'm on the top half. And you might want to scroll over just a little bit to make sure. And maybe I shouldn't have gotten so close so that you can really see that your cursor is on either part of the graph you're looking for. So I'll hit enter for that and enter a third time. And it gives me this weirdo number here, but that's really just a 0. So it's going to be 0, 1 for my other intersection point. So I'm going to go back to my graph here. I'm going to sketch a little ellipse in. Oops. I don't know why that keeps coming up when I'm doing the videos. And then I'm going to sketch my line in here, trying to make it go through 0, 1. Oh my goodness. I'm sorry, that's super annoying. All right, and then we get 0, 1 for this. And negative 2/3, negative 1/3. Now, algebraically, it's not really going to be that much work. And technically, if I'm asking you to do both algebraically and graphically, you could do the algebraic first. For substitution purposes, I'm just going to take my 2x squared. I'm going to put in to the y, the 2x plus 1. This should be a situation that you're fairly comfortable with at this point. And then FOIL. Simplify it down a little bit. And a little factoring. Okay, and then we would get one of our x's is 0, and one of our x's is negative 2/3. So already seeing the values that we got graphically. Then the easiest one to plug back into is the line. So I'm going to plug in y equals 2 times 0 plus 1. And then y equals 2 times negative 2/3 plus 1. Get both of our answers there. And then just make sure for your solutions, you write them as coordinates because they are solution points. And we end up getting the same 2, obviously, that we did graphically. But the graphically is a good way to check it. If I ask you to do both, graphically you should show the picture, the intersection points labeled, and then algebraically you want to show all your algebraic worth. You don't have to show every single step, but you should show enough steps to show whether you're doing substitution or elimination. Okay, so that's our first one, and that was an easier one to do a substitution, which is why I showed it that way. In your second video, you'll see one done graphically and then algebraically by elimination.